Okay, everybody, here's the order of the way that we're going to do things today. Before we even start this, right now everyone needs out their notes and the worksheet homework for the day, because I want to get everyone started on that, because some of you are going to immediately start on that if you're finished with your test, and I want you to be ready to go. And then everyone will start on it eventually. You'll start on it when you're finished with your test. So let's begin there. So what we're going to do, again, finish test, do the homework assignment, quiet study hall is the period. A lot of people were absent on test day last week, so it needs to be a quiet period because a lot of people are just starting that test for the very first time. Okay, here is what I want us to write in our notes. So you guys might pause the video here to have this down, but basically this breaks down linear and exponential equations, which were a huge part of AGS 1. We haven't even been thinking like this. We've been thinking about probability and statistics, so this is totally changing gears for us here. And for a linear equation, it's y equals mx plus b, or f of x is replaced for y, just to show you that it's a function. And the recursive is f of x equals f of x minus 1 plus m, and we'll talk about both of those right now. So first of all, you have to decide which one. Is it linear or exponential? This one is linear because it is adding 2 each time. This one's exponential because it's timesing by 2 each time. So that's kind of how you tell the difference between the two. So what you want to do with the linear, first of all, is figure out what b is. And b is the y-intercept. Okay? So the y-intercept is where the graph crosses the y-axis. So what we really need to do is figure out when x is 0, what is y? Because that tells us where it crosses the y-axis. So we have to work back in our table a little bit and think about, okay, well, if 2 is 5 and it's adding 2 each time, 1 must be 3 and 0 must be 1. This tells me that b is equal to 1. The y-intercept is 1. So look at what's across from 0. M is the rate of change, and we already talked about how this was adding 2 each time. So this is equal to 2. So your explicit equation for this table is y is equal to, or let's get in the habit of writing it as a function. F of x is equal to 2x plus 1. And then you can always check to make sure that it works. So if I plug in 5, I better get 11. So if I put 5 here, 2 times 5 is 10, plus 1 is 11. And this is all from last year. So there's your explicit equation. Recursive looks big and scary, but it's actually not. F of x is equal to f of x minus 1 plus 2, okay? Because m is the rate of change. So what that means is, if you really want to see that explained, it says if you want to get f of 3, okay? Now in this case, we know that f of 3 is 7. So if we want to get f of 3, we need to take f of 3 minus 1 and add 2. So f of 3 is f of 2 plus 2. So f of 3 is, well, what is f of 2? F of 2 is 5 plus 2. So f of 3 is 7. So again, it's not that complicated. It means if you want some term, you take the term before it and add 2. Explicit equation. A is the start value, and B is the multiplier. So your start value is across from 0 again, and it is also hidden in this table. So the start value here, well, if it's doubling each time, this must be 1.5. And then the multiplier, so in this one, A is 1.5, and the multiplier is 2. So my explicit equation would be f of x is equal to 1.5 times 2 to the x power. And then I just like to kind of check that too. So if I plug in 3, I should get 12. So 2 to the third power is 8, and 8 times 1.5 is 12. It works. Some of you guys might have written it a little bit different last year depending on who your teacher was, but maybe you learned it as f of x is equal to 3 times 2 to the x minus 1. If you learned that, that's great. Okay, recursive equation is just as easy as it was over here. F of x is equal to f of x minus 1 times 2. So to get the next term, we take the term before it and multiply it by 2. So you need to take this thinking and apply it to the worksheet. So let's just do 1 or 2 of these to get you guys started. So you need to look at your sequence or whatever and try to decide what it is that's going on. So this one is adding 7. So that tells me that m is equal to 7. And then b is the start value. So for this, a lot of people want to think that the start value is 14. But if this was in a table like this, basically term 1 would be 14 and term 2 would be 21. So you got to work backwards and get term 0 actually, which is 7. So this one is y is equal to 7x plus 7. And then you just double check it. Like when I plug in 2, do I get 21? Yes, I do. 7 times 2 is 14, plus 7 is 21. So that's how that one works. So you're just deciding if you're adding or multiplying each time. So let's look at 3. Okay, so 3, it's getting smaller. It's not subtracting something, because if it was, this would be like a huge subtraction and then a little subtraction. So it's getting smaller, and most of us would probably say that it's dividing by 7. But remember, it's a multiplier, not a divider. So the same thing as dividing by 7 is the same as multiplying by what? By 1/7. Okay? So that tells me that the multiplier is 7th. And my start value would be term 0, the one back here, okay, before 49. So that would be 49 times 7, which is 343. So the explicit for this one would be y is equal to 343 times the 7th to the x. And again, your teacher might have taught you last year to go y is equal to 49 times the 7th to the x minus 1. And that's fine too. I should do the recursive for these two. So f of x is equal to f of x minus 1 times the 7th. Okay? And up here, this would have been f of x is equal to f of x minus 1 plus 7. So that should give you enough to get through 2 and 4, and this page too. And this will all be due on the day I get back, but this is our order right here. Okay, so if you're not done with your test, start with that now. If you are done with your test, complete that homework assignment I was talking about and have a quiet study hall, and that will be a day. Thank you.